I've brought its 314 reactor, and today we are looking at 3DMark, the newest version of 3DMark, which was released in 2013. Now, this one has a enormous technical guide for it with 153 pages. So when I was complaining about the previous white papers only having a few pages, this one has gone crazy. This originally released with 3 tests on it: CloudGate, Ice Storm, and Firestrike. Now, a number of these have now become legacy benchmark tests, such as Skydiver, the API Overhead Features Test, CloudGate, and Ice Storm. Now, the reason why these have been deprecated is explained here, because they just become unsupported and too old to run on modern hardware, and a lot of these were deprecated at the beginning of the decade. So the ones we're going to be looking at today, CloudGate, I just don't think it's got enough juice behind it anymore to stress mid-level PCs, which this was originally meant to do. This was originally meant to test Windows notebooks and home PCs with integrated graphics, and it's now too lightweight for modern hardware. And there's a replacement called 3DMark Wildlife or 3DMark Night Raid to benchmark PCs with either Vulkan or DirectX 12 with integrated graphics. Ice Storm Extreme, again, is now too lightweight for modern mobile devices. I know that because whenever I've run Ice Storm Extreme on my mobile phone, it completely maxes it out and gets an enormous score on it. But you can still access them by checking a box saying show unsupported tests, which is great because it means you can maintain them forever. I was worried for a while that they'd been taken off because this has become sort of a live service thing now. It gets updated live with new benchmarks and stuff. They're not released separately. You just download newer benchmarks as DLC. So as you can see here, looking at 3DMark, I've got this on Steam. You get the initial version, which is free, and then you can upgrade it to Advanced Edition, and then you can buy different DLCs for it. And the best thing is that you can maximize it. So that's really cool. So you can see here, we've got the recommended benchmarks for the system here, which show the newest benchmarks for DirectX 12, CPU, and storage benchmarks. It's got my system details here. So I've got the RTX 4090 with the Radeon graphics built into Ryzen 7 7700X 8-core processor with 32 gigs of RAM and a number of NVMe SSDs. Now, if we go to benchmarks and we've ticked show unsupported tests, you can see all of the benchmarks that there are. So cool to see so many benchmarks. I was saying that 3DMark 2000 was the best 3DMark, but I'm starting to think maybe this one is, because it's just got so much variety and the UI is really nice. It's got the niceties of the modern UI, but it's got lots and lots of cool tests. The ones we're going to be looking at today are the original tests that came with it, which is Firestrike, which is the heavy duty test, Ice Storm, and CloudGate. Now, over the years, Firestrike has been updated from just the DirectX 11 benchmark to an extreme one, all the way to an ultra one for 4K gaming with DirectX 11. You can see there's other ones here. There's DirectX 12, there's ray tracing, there's mobile computing ones, there's more DirectX 12 stuff. There's a cross-platform test for mobile devices, Wildlife. There's Night Raid, DirectX 12 for PCs with integrated graphics. There's the CPU profile. There's a storage benchmark. There's a ray tracing feature test. There's a mesh shader feature test. There's a PCI Express feature test, AMD SFR test, VRS test, sampler feedback feature tests, Intel XESS feature test, and DLSS feature tests. These are the unsupported ones now. Skydiver for DirectX 11 PCs. CloudGate was for basic notebooks and home PCs, and Ice Storm was for low-cost mobile devices. And then there was the API Overhead Feature Tests when DirectX 12 came out, as well as VRMark Preview, which came out in 2016, alongside the Oculus Rift CV1 release. But this hasn't been updated since, which is interesting. So anyway, we're going to keep it simple for this video. We will get through all of these. It's going to take a while. I didn't quite realize how many benchmarks there were built into this. Let's just look through the menu here a little bit before we start diving into that. You can stress tests here, so you can select any number of the existing tests, which will run continuously for 20 loops without pausing or reloading between loops, and a full test lasts around 20 minutes. So it's basically just a way to ensure that your overclock is stable, your PC is stable. Then you've got the results browser here, where you can look through the results of a previous test with some really decent monitoring. You can compare the results online, as we've seen before. It's got some really nice details here, which is really cool, actually. It's got all the CPU temperatures, GPU temperatures, frame rate, clock frequencies, GPU load, CPU load, everything you could possibly want to look at. And then, of course, you've got the options here, which just give you standard options: GPU count, scaling mode, and you've got the GPU count, scaling, demo audio, language, scaled resolution, validating results online, scan system info hardware monitoring, support, and then you've got all the different version details, and of course you can show your product keys. Nice UI, I really like it. It's also got that kind of Deus Ex Human Revolution kind of polygonal look in the background, which reminds me of the GTX 1080, which is really cool. So the first thing we're going to dive into is Firestrike Ultra. We're not going to run normal or extreme. We're going to run the absolute maxed out Ultra so we can get the absolute best looking effects out of it. The lower end ones just have fewer effects. So you can see kind of the preview here is less particles and less flames, and this one has absolutely everything going for it. So the first thing we can do is check out the technical guide to see what that says about the technology being used behind this. It's a DirectX 11 benchmark, and it has 2 graphics tests, a physics test and a combined test that stresses both the CPU and the GPU. And 3DMark Advanced and Professional Edition includes Firestrike Extreme and Firestrike Ultra, 2 benchmarks designed for high-end systems with multiple GPUs, SLI Crossfire. This is, shows how much of an old benchmark that is. Now, this is the latest technical guide, I believe, from 2021, so they should have reworded that really, because even by 2021, SLI and Crossfire, I don't think are really a thing anymore. So you got some details here on Firestrike and Firestrike Extreme, and then Ultra is meant for 4K, and it says, yeah, you must have at least 3 gigabytes of VRAM here, and we are way over all of these specs, so I think we'll be okay. Graphics X1 focuses on geometry and illumination. Particles are drawn at half resolution, and dynamic particle illumination is disabled. There's 100 shadow casting spotlights and 140 non-shadow casting point lights in the scene. Compute shaders are used for particle simulations and post-processing. Pixel processing is lower than in Graphics Test 2, as there is no depth of field effect. So you can see there's just details, tessellation patches, triangles, pixels, compute shader, invocations, just millions of vertices, triangles, pixels, compute shader invocations. Crazy how much is going on. And again, we're using compute shaders for particle simulations, which means PhysX has been long left behind, and it's now just using API level compute shading to calculate particles. GPU Test 2 focuses on particles and GPU simulations. So particles are drawn at full resolution, dynamic particle illumination is enabled. There are 2 smoke fields simulated on the GPU, 6 shadow casting spotlights and 65 non-shadow casting point lights are present. Compute shaders are used for particle and fluid simulations and post-processing steps. So yeah, this is a bit more of a focus on the particles and GPU simulations. And then the physics test is where it shows the hardware's ability to run gameplay physics simulations on the CPU. The GPU load is kept as low as possible to ensure the CPU is stressed. The Bullet open source physics library is used, which is the one they were using in 3DMark 11 as well. The test 32 simulated worlds, 1 thread per available logical CPU core is used to run simulations. All physics are calculated on the CPU with soft body vertex data updated to the GPU each frame. And then you have the combined test, which of course combines GPU and CPU simultaneously. It uses all the elements from Graphics Test 1 and 2 using tessellation, volumetric illumination, fluid simulation, particle simulation, FFT-based bloom, and depth of field. And FFT bloom means fast Fourier transform, which is used to accelerate the calculations of the scattering of the light. Again, I'll put links in the description to all of this to help explain it a little bit better, but essentially fast Fourier transform is just an algorithm that can compute a sequence, so the bloom should look really good in this one. Again, we are well beyond the early days of HDR and bloom now, but all the HDR lighting and bloom should look really spot on and really nice. And it's good to see the Bullet open source physics engine back again from 3DMark 11. So again, you got some information about the scoring here, how that's calculated, and then it's got some information about the actual engine itself, which of course requires hardware with full DirectX 11 feature level 11 support. It's got multi-threading based on DX11, and the rendering workload is distributed between the threads by distributing items, for example geometries and lights, to different threads. It has tessellation, which uses PN triangles, Phong and displacement map based tessellation, and both triangle and quad based tessellation is supported. And this also has hull and domain shaders. Wow, I'm gonna have to look into those at some point. The lighting is done in a deferred style. Geometry attributes are first rendered to a set of render targets. Ambient occlusion is then computed from depth and normal data. Finally, illumination is rendered based on those attributes. The surface illumination, so there's some details here about the different diffuse levels and specular reflectance or Phong shading. Simple surface shading model is used on feature level 10 demo and tests, while the complex model is used on feature level 11 demo and tests. Horizon-based screen space ambient occlusion can be applied to the surface illumination, so the ambient occlusion looks really good because HBAO looks a lot better than standard SSAO, and that was becoming more of the norm at the time. And then there's point, spot, and directional lights being supported. Volumetric illumination, which is computed by approximating the light scattered towards the viewer by the medium between eye and the visible surface on each lit pixel, which I think is the same sort of volumetric illumination they were using in the submarine level on 3DMark 11. So it should be a more advanced version of that. In fact, yeah, it says volume raycasting and Rayleigh-Me scattering. And it has some more details about that. Again, it's got some very basic raycasting, which is cool to see. And then there's particle illumination that's supported supported here. Particles are simulated on the GPU, and particles can either be self-illuminated or receive illumination. And there's all sorts of details here about how those particles can be textured, again using hull and domain shaders. You have to look into those. And particles can cast shadows on opaque surface and other particles. For generating particle shadows, particle transmittance is first rendered to a 3D texture. The transmittance texture is rendered from the shadow casting light like a shadow map. After particles have been rendered to the texture, an accumulated transmitted 3D texture is generated by accumulating values of each depth slice in the transmittance texture. So yeah, it's using some sort of texturing technique here to cast particle shadows, which is crazy, a 3D texture. And then it can use that data to illuminate other particles. Post-processing, particle-based distortion, nice depth of field. So of course, this should be the era of bokeh depth of field. Using geometry shaders, the image of a hexagon-shaped bokeh is splattered to the position of vertices. As you've seen in the demo, this doesn't run entirely fast, even on a 4090. Even though I did have MSAA quite high, it's still quite heavy to run because obviously there's just so much being calculated here. Lens reflections, details here about more FFTs. It uses fast Fourier transform to transform the computed illumination to frequency domain, using 32-bit floating point textures to compute that. Anti-aliasing, this is where it starts to support FXAA as well as MSAA. In MSAA method, G-buffer textures are multi-sampled with a chosen sample count. Edge mask is generated based on the differences in G-buffer sample values. I'm guessing this is how they get around MSAA on deferred rendering, because when deferred rendering first came out, MSAA did not support it, so I'm guessing they had to use some stuff with the G-buffer here to get that to work. This is a lot of stuff I need to read into, just trying to understand this as I go through it. And then there's smoke simulation, which is based on Ronald Fedke's paper, visual simulation of smoke with the addition of viscous term as in Joe Stam's stable fluids but without temperature simulation. Thus the smoke is simulated in a uniform grid where the velocity is modeled with an incompressible Euler equations. Advection is solved with a semi-Lagrangian method. Okay, I think what I can take from that I understand is that it's done with compute shaders. Wow, I'm going to try and find these papers here as well. So, after all that mind-blowing technology, let's dive into Firestrike Ultra here. And you can see we've got a whole load of tests here where we can include the demo, we can do the graphics test 1, 2, physics test, or combined test. So what we're going to do is we're going to save the demos for all three until the end of this video. And we're going to do graphics test 1, 2, physics test, and the combined test. We're running at 4K. We're going to have the anisotropic filtering at max. We're going to have MSAA at max. We're going to have tessellation level detail at max. Max tessellation factor maxed out. Shadow map size completely maxed out. Surface shadows, volumetric quality, volumetric illumination sample count, particle illumination quality, ambient occlusion quality, depth of field quality. And we're going to put the color saturation up to 100%. Nice load of options. Not quite as many as there would have been in previous 3D marks, such as 3DMark 2006, where you could flick between pixel shader models, but there's probably not much need for that by this point because it is testing very specific hardware, and you're probably not going to be able to flick between, you know, shader model 4 and 5 or anything like that. And also generally when they did that back then, the differences between the pixel shaders weren't that great because they had to limit the tests to the older pixel shaders. So it makes sense. So let's run this. Okie dokie, so here we go. We are at 50 frames per second, and you can see all the really nice lighting effects going on here, and the really cool lava. So this is more when it's focused on the lighting rather than particle stuff. God, those volumetric lights look so nice. And then we're entering graphics test 2. This is where the particles are being calculated. So this is very much focused on particle simulation, smoke effects. But it still has some of the effects from the first graphics test. And that had smoke fields with some spotlights, fluid simulations. And then we are on the physics test. So this is the soft bodies being calculated by the CPU. 32 simulated worlds. So I'm guessing it's doing this multiple times over in the background. It's not just what you're seeing there. And here's the combined test, which has graphics test 1 and 2 with all the fluid simulations, particle simulations, depth of field, bloom, and it also has the rigid body physics of the braking statues in the background. And there's 32 simulation worlds running in separate threads, each containing one statue decomposing into 113 parts. Wow. Now we're down at 30 FPS. See, the physics test ran really well, so I'm wondering if the CPU isn't the bottleneck on this anymore. It's more the GPU, just because of the high amount of MSAA running. But it does look really good. And these tests run relatively quick, just like they did in 3DMark 11. And here we go. We have the detailed breakdown here, the graphics score, the physics score, the combined score. You can see the frequency of the CPU, the GPU, and the GPU memory clock going up and down. All the details of the test, all the details of the hardware, detailed monitoring. Look at that. So you can see 30 FPS there, 28.93 FPS. Temperature, there's a temperature spike here at the start of graphics test 2. Huge spikes here with the CPU, of course, on the CPU test. The Ryzen getting to 92 degrees. Wow, but the frame rate's, like I said, the frame rate is the highest in the CPU. You see the GPU load drop there in the CPU test, which of course makes sense. Definitely the best results output of any 3DMark. The CPU gets really hot and the GPU doesn't get anywhere near as hot, which is the same with my laptop, which has a 3060 in it and a Ryzen 5500, I believe. And yeah, the Ryzen always gets to like 90 degrees, but the GPU always seems to sit about 60 odd. So it's interesting that the Ryzen gets so hot, but the NVIDIA RTX cards don't seem to get as hot. Relatively stable clock frequencies along the way, at least for the GPU, which makes sense. The CPU is a bit more up and down. Obviously, as the temperatures go up, the clock frequency will go down to try and balance that out. The next one we're going to test, which is CloudGate, which was for basic notebooks and home PCs. So let's head back to the technical guide and see what it says about this. So I've had to go back to the 2018 version of the technical guide here so that we can read about CloudGate, as it's been removed from the technical details of the newer one. Again, there'll be a link to the description to both of these technical guides. It uses DirectX 11, feature level 10, and it's suitable for DirectX 10 compatible hardware. So it's DirectX 11, but it can run on DirectX 10 hardware. So there's a comparison here between CloudGate and 3DMark Vantage. So of course, Vantage and this are for DirectX 10 essentially. 3DMark Vantage released in 2008 uses a DirectX 10 engine. 3DMark CloudGate uses a DirectX 11 engine limited to Direct3D feature level 10. Using Direct3D feature levels is the modern approach to game engine design, as it allows developers to use a DirectX 11 engine and still support older generation hardware all the way down to DirectX 9. Graphics setting 1 has a emphasis on geometry processing while having simple shaders. Volumetric illumination is disabled, but the scene contains particle effects, FFT bloom, and depth of field are added as post-processing steps. Graphics test 2 is shaders that are more mathematically complex, less geometry, simple volumetric illumination, but the scene has no particle effects. There's a physics test, which has 32 simulated worlds, each with 4 soft bodies, 4 joints, and 20 rigid bodies colliding with each other, and they run on 1 thread per CPU core. And again, it uses the Bullet open source physics library. There's some information about the engine here. It uses the same engine as Firestrike, with a reduced set of features, including a simplified lighting model, and some fallbacks implemented for Direct3D feature level 10. Back on the UI here. Let's go into CloudGate. We're going to do enable graphics test 1, 2, and 3. We'll do the demo again later. We're going to run it at 4K, full and ISO again, everything maxed out again basically. Let's dive in. Now, this one I'm fairly certain, as you can see just from the loading screen here, I'm fairly certain it uses a lot of assets from Shattered Horizon that we looked at a couple of weeks ago. So that's really interesting. So you can see there's the big ship here with the solar panels and stuff on it. Depth of field. Now this looks quite good. You can obviously see the limitations, given that it's old and that it's running on lower end hardware, or at least was supposed to run on lower end hardware of the time. But it still looks pretty good and shows that for lower end hardware of the time, things were moving pretty fast, because 6 years before this would have probably been a full gaming PC benchmark, which is pretty crazy to think about in terms of evolution of technology. In fact, it was about a year after this NVIDIA released their first gaming tablet, which would run Doom 3 and Half-Life 2 really, really smoothly, and probably better than top-end PCs would have done a few years prior. So again, technology just flying forward always bewilders me. And this is the perfect example of that. And now we see the physics test. Again, this is where you got rigid bodies, soft bodies, multiple worlds being simulated. And the frame rate is actually lower on this one than it was on the CPU test for Firestrike, which is really interesting. Again, here we have the results here, a lot more detail. So yeah, the temperatures are still pretty high. I'd have thought they'd have been a bit lower because there's less being processed, but there you go, it's still using all the GPU on it. Insanely high numbers here. Graphics test 103 FPS, graphics test 2 91 FPS. I'd still expect more FPS from a 4090 on this, but I'm guessing it's probably because of the mix of the FXAA being so high and the other settings being all maxed out. And also the fact it's probably using the DirectX 10 feature set, which maybe isn't as performant as the DirectX 11 features. I'm imagining it's probably because I just have these settings so high. But again, really nice looking test, especially for what it is. It's just meant for home PCs with integrated graphics. It just, again, shows how far technology even in 2013 was. And then we have Ice Storm Extreme for low-cost mobile devices. Again, we're going to be running the most extreme versions of these benchmarks, and there is an Ice Storm for basic smartphones and tablets, which has just reduced graphical set on it here. Again, you can kind of see from the screenshot there's just less stuff going on. So we're going to check out Extreme. Let's go to the technical guide from 2018 and see what it says about the technology and the engine. This is a cross-platform benchmark for basic smartphones, tablets, and older mobile devices. We recommend using TimeSpy, Firestrike, and Skydiver for testing modern PCs. So you can run it on modern PCs, but it's really meant for mobile devices. So it contains 2 graphics tests focusing on GPU performance and a physics test targeting CPU performance. So essentially the same as CloudGate. On Android and iOS, Ice Storm uses OpenGL ES 2.0, so I'm guessing this is before iOS's Metal API. And on Windows, it uses a DirectX 11 engine limited to Direct 3D feature level 9. So again, similar to CloudGate. And yeah, really low requirements here. What would be cool is to run this on an actually really old PC, possibly a 3DMark 2006 era PC. I may try that at some point and see how this runs, if it runs at all. So you can see the standard test is limited to 720p and it's scaled to the latest resolution of the display. And Ice Storm Unlimited, which you can use to make chip-to-chip comparisons. Ice Storm Unlimited uses the same content and settings as Ice Storm, but runs off-screen using a fixed time step between frames. Ice Storm Unlimited measures the performance of the device hardware without vertical sync, display resolution, scaling, other operating system factors affecting the result. Graphics test 1 stresses the hardware's ability to process lots of vertices while keeping the pixel load relatively light. Hardware on this level may have dedicated capacity for separate vertex and pixel processing. Stretching both capacities individually reveals the hardware's limitations in both aspects. Pixel load is kept low by excluding expensive post-processing steps and by not rendering particle effects. Graphics test 2 stresses the hardware's ability to process lots of pixels. It tests the ability to read textures, do pixel computations, and write to render targets. The additional pixel processing compared to graphics test 1 comes from including particles and post-processing effects such as bloom, streaks, and motion blur. The numbers of vertices and triangles are considerably lower than graphics test 1 because shadows are not drawn, and the process geometry has a lower number of polygons. And then there's the physics test, which is of course meant to benchmark the CPU, which has 4 simulated worlds. Each world has 2 soft bodies and 2 rigid bodies colliding with each other, and there's 1 thread per CPU core used to run simulations, again using Bullet open source physics library. And then there's some information about the engine itself, which is only on 1 page. So it uses the same engine on all platforms, and the engine supports traditional forward rendering, multi-threaded scene updating, draw calls from a single thread, support for skinned and static geometries. Surface light model is basic blend Phong. It supports unshadowed point light and optionally shadow map directional light, as well as pre-computed environment cubes. Support for transparent geometries and particle effects, and 16-bit color formats are used for illumination buffers if supported by the hardware. And this can also run on Windows RT, which I don't even know if is a thing anymore. I think that was for Surface. Final release 2023. Yeah, Surface and Nokia Lumia. So it's a mobile sort of device operating system meant for 32-bit ARM architecture. Okay. Sort of the Windows 8 era. Oh, Windows 8, wow. Microsoft and its subsidiaries no longer manufacture any Windows RT devices. Put a link in the description to this as well, because this is really interesting. And then on Android, Ice Storm does not use any vendor-specific OpenGL 2 extensions. Textures compressed using ETC, and textures that require an alpha channel are uncompressed. And textures on those with an alpha channel are compressed using PVRTC, which I'm guessing is some sort of iOS-specific hardware texture compression. So this is going to be the most basic of the tests. It's going to be funny to just run it with everything absolutely maxed out at 4K. Let's do this. So here we have graphics test 1, which is going to be mostly focused on geometry, and it uses old chip models and stuff from 3DMark Vantage, which is really interesting to see, and the overall graphical level is probably around that of 3DMark 2005, which is really interesting because, again, It shows how you can go from a huge box PC that needs plugging into the mains to run this, to having it run on a tiny foldable phone that can fit in your pocket. Again, showing the crazy advances of technology. Now this is the pixel based test. You can see here's lots and lots of pixel shading going on here, lots of particle effects. Huge frame rate. I mean, it's running like hundreds of frames a second, which isn't surprising. Oh, look at those nice ice meteorites there. Wow. Or asteroids. What are they called? Asteroids? Meteorites? Comets? I think comets. Either way, it looks really, really nice. Really nice effects there. And then you have the physics test, which kind of has blobs on it that remind me of the blobs from Unreal. I believe Return to Narpali. Or the blob creatures from Crash Bandicoot 1. Really, really cool. Really, really cool. And again, the background there looks like it was from 3DMark Vantage. Here we go with the results. So yeah, the graphics score is 116,000. The physics score is 95,000. The physics test got 302 FPS. The graphics test got 560 FPS. And the graphics test 2 got about 562 FPS. And even then, it's still using quite a lot of the GPU load. But under the CPU score, the CPU doesn't get anywhere near as hot as it did in previous CPU tests, which makes sense because it must be vastly more simplified. Again, those really cool results. Really, I love this report here. It's so good. So yeah, that was Ice Storm. So that has covered off the benchmarks of the 3 tests that I wanted to check out. Now we can go to the demos now. So let's set everything up, max it all out again, and let's dive in and I'll talk through the demo. The first time I would have run this, it would have been on my 570 that I got back in 2012, and then I'd have run it on my 760, and then on my 760 SLI system that I had, then on my 980, and then my 1080. So that's mainly where I have my memories from this from, and each time being able to run it faster and faster and faster. But of course, even right up to my 4090 now, the 4K version of this running this maxed out, the frame rate still doesn't go too high. Of course, there's no way I was going to be running it with 8 times MSAA back then, whereas now I can. You see the frame rate dipping there? Look at those particles, liquid effects. See, this one is a little bit more abstract, but also feels like a video game. So it kind of has the best of both worlds. And it still looks fantastic, despite being about a decade old. Just look at those particle effects. And the sound effects. The amount of effort that must have gone into this. It looks like it might even be using motion capture, I don't know. Man, that looks so good. And the bokeh depth of field still looks incredible now. And the person wearing like a stealth suit there. The music is amazing. I mean, this looks fantastic. Oh, it's so good. Look at that depth of field. Oh, that brings me right back to 2013. That look was all over the place back then. I don't think it's used as strongly now. Oh man. But back then it looked good, because I think it was new. Yeah, it was new to DirectX 11, so yeah. Just like when HDR and Bloom became a thing, it was just vastly overused, but I wasn't complaining. Look how good that looks. Oh man, then the sword lands, and then, oh, the particles flying out. Oh man, it reminds me of the Foundry on Doom 2016 as well. Oh man, what a time. What a time. So yeah, again, this spits out some details, some reports, even on the demo version, so you can still get temperatures and frame rates out from the demo. Of course, it doesn't give a score because it's just the demo, but it will show you the settings and results, as in the frame rate, temperature, and percentage usage to the GPU, as well as the frequency of the GPU and CPU. Let's move on to the next demo, which will be CloudGate again. Alrighty, so we have all the settings maxed out, and we're going to run the demo of CloudGate. So again, this is where we see a lot of the assets and style from Shattered Horizon. MMC, I think that might even be one of the factions from Shattered Horizon as well. I wondered if this is part of the universe of Shattered Horizon. It would actually make sense. Which means I wonder if there's a 3DMark shared universe. That would be cool. Where somehow all the abstract stuff from 2000 links in to the distant history of some of the more medieval stuff in the later 3DMarks, which then is the history of this future stuff. The shared 3DMark universe. That would be pretty cool. Whether it's a thing or not, I don't know. But we can safely assume that this demo takes place in the same universe as Shattered Horizon. Most likely a prequel to Shattered Horizon. You get a good sense of scale by this point, because there's enough detail on the geometry and lighting and stuff to really give a sense of size. As opposed to the prior 3DMarks where you'd have a dragon flying over a city, but the city feels like it's more of a Lego set than an actual city. The only thing that doesn't really look too good is the smoke effect there. Looks very much like some 2D sprites. We have a nice little output here. The ups and downs of the frame rate. Never really dips below 100, except for here where it hit 98.34. The GPU load actually dropped a bit. Not sure what caused that dip. And now we finish up with Ice Storm Extreme demo. Again, full settings, 4K. So we have all the settings maxed out. Again, same as we did with the benchmark. The tests off and the demo on. Let's do this. So these demos are pretty mind-blowing so far. Really enjoy the music, the aesthetic, and how they all kind of link into previous 3DMarks as well. That's pretty cool. I still think... I mean, the Firestrike one is pretty abstract. I still think they could be a bit more abstract, like the older 3DMarks maybe. Oh, this is cool though. See, I can imagine this being in the same universe as 3DMark Vantage. The huge space battle in that. And I can imagine that being in the same universe as Procyon in 2003, 5, and 6. But yeah, it'd be good to take modern day ray tracing and make a really abstract demo with it. In the older style of 3DMark. Like a 3DMark 2000 style, bizarre, abstract. Yeah, I don't know. It'd be cool to see it again. I really like the reflection on that buzzsaw there though. I do like a lot of the imagination being employed in this as well. Like a big machine that has a cutting saw that cuts a ship in half. That's pretty awesome. And the ice effects look really good there. Oh, that's nice. Reminds me of the ice effects from Halo. And again, yeah, look, the machines are basically throwing a huge icy comet at a ship. That's awesome. Oh, that is cool. Yeah, I love these demos. And there we go. Nice little report at the end. That is the first 3 benchmarks that originally came out with 3DMark 2013. Next week, I may look into running a proper test on this one, setting my drivers to be default and running the default ultra test and getting a score, see how my computer actually squares up against other PCs with a real result online. And then we'll probably look at the next demos that came out for this, or the next benchmarks that came out for this, which I believe would have been Skydiver, the API overhead feature test when DirectX 12 came out in 2015. I got a lot of nostalgia for that one because I distinctly remember running that at the time. But yeah, that was 3DMark, the latest one that's been going for over 10 years now. So that's what I mean. It's become more of a sort of live service thing, and ironically has lasted longer than most games that intended to be live services that were going to last 10 years. This one actually has lasted 10 plus years. And like I said, really nice UI, really cool tests, and yeah, I really enjoy it so far. So it'd be really cool to check out some of the newer ones, especially these DirectX 12 ones. And Port Royale is a really nice ray tracing benchmark. Yeah, stay tuned for that. Subscribe, leave a comment, let me know what you think of 3DMark and the journey we've been on through 3DMark. It's going to be a bit sad when I run out of 3DMarks to look at, because it's been a really good few weeks, a really good series. There's always new videos coming out on video games and graphical technology and tech projects. Thanks for watching. Hope everyone's staying safe, and I will see you in the next video.